Do you need someone to write the board?
No, not really. It's quite simple, I think.
Alright. Ready? Are you now ready?
Yeah.
Alright, good. Great. Alright, so let's go to Santiago.
Okay, so the task, the performance task is to draw a square on the graph paper of size 5 centimeters and use it to determine the value of 5 squared. What is the area of the square?
Okay, so
Let me just say my topic would be area. Yes. Okay, so my checklist, my objectives. Do students use straight lines for square? The ability to use the graph paper to get 5 centimeters. Are all sides of the square equal? Awareness that the number of squares inside is the same as 5 squared. And ability to link the space inside as area.
very good. Now the one I'm not sure about is the first one. Could you repeat that one?
Which one? The ability to, the students using the straight line?
To draw a square.
Yeah.
Okay, I see. Alright, I'm fine. Very good. Alright.
Yeah.
Mona, do you want to go now or should I allow Bermuda to go?
We can go.
Alright, so come, why don't you come and explain? I recommend that you stand because I can hardly hear you in that corner there. Okay, please don't let me hear you tonight.
You know what you think?
So tell us a topic. Tell them a topic.
Guess I have to know.
The lottery.
Alright,
It's
our topic is investigating the value of pi, or finding the value of pi.
Yeah, proving pi or something.
Proving the value of pi. The performance task is to construct a circle and
They use a string.
mhm,
They're going to use a string to measure
the diameter
the diameter of the circle using a string. They're going to use another string. And I guess probably just use a string and then cut that length. So if they measure the diameter, then cut that length and put it one side. Then you get another piece of string and measure the circumference around the circle and cut that. And then cut that string as well and put it one side. And then I guess use the diameter and show that 3 at the diameter and just a little bit more.
or the task would be see how much of the diameter makes up the circumference. So this first string, see how much of that makes up the full circumference. And that should give us
Circumference that equals 2 pi r, which is the same as pi d. So you can divide the circumference by the diameter, then you should get pi.
so the task is to divide the circumference by the diameter times pi.
And the performance task would be 1, they understand the concept of a diameter. Okay. Then the checklist. Then the checklist would be 1, understand the concept of a diameter, meaning if the students understand that they must go through the center and not just measure from here to here, so like they measure a card. Next thing would be understand the concept of circumference, see them measure the length around the circle. Distance around the circle. And it's the concept of division.
Yes, the concept of division. If they can actually divide
The circumference.
circumference by the diameter.
And And I guess it will look a lot of such an approximation the answer that we get.
So if they know that it is 3.9
Between 3 and 4,
versus
yeah.
3.5.
They never get the answer 4 or something like that.
Okay, very good. Good job. Okay, do we understand that?
Yeah.
Bermuda, could you follow that? You know where we're able to follow or not really?
Not really.
Not really.
Alright, so let me try and explain. So you know how there's a relationship between this, pi. I was like pi
Yeah.
is 22 over 7 or 3.142
Yeah.
or 3.14.
Yeah.
Alright. So what they set out to do is to show that number 22 divided by 7 or 3.142, it didn't come from the sky or it didn't just appear.
Okay.
So they used this circle, like a circular object, and to prove pi. So they use the circular object and then measure the circumference of. They use a piece of string to measure the distance around the circular object, and then they cut that string there and have it. Clear so far?
Yeah.
Then they got another piece of string and they measured the distance from one end or the diameter, which should go to the center from one end to another end of the thing. Alright? So they measured the circumference, cut that string, put it down. They took another piece of string, measured the diameter, cut that string now, and put it down. Now, they're going to compare. So when you order the string for the circumference and the one for the diameter, you'll obviously see that the circumference is bigger than the diameter. But you want to figure out how much bigger. So you can measure it. So you use the string of the diameter to measure it. And then you'll see that it's 3 and some more. Are we clear?
Okay.
And that is how pi came about. So the pi, so the idea of pi is the circumference divided by the diameter. That's how you get the value of pi. And it works for all circles. Doesn't matter how large the circle is or small. Once you make the circumference and the diameter and divide it, you will always get the value of pi. Are we clear?
Yes.
Okay. Now I have another one. I did one because I was waiting so long. So this one is it's a triangle. Can you all see this?
Yeah.
So this one is to prove the sum of interior angles of a triangle. So we have several different ways. What are different performance tasks could give us today to do this? They could use their protractor and measure it, and measure all the angles and then add them up. Agree?
Yeah.
Yeah.
Or we could take out the angles. This is the first angle. Agree?
Yeah.
This is the second one.
Yeah.
Agree? And then I'm taking out the third angle. So I need to do something with these 3 angles that I've taken off to prove that it adds up to 180. Can we all follow that so far? So I'm going to put them together to show that, so I'm taking the angles, putting the angles together, to show that if I put them together, what I'll end up with is a straight line.
A straight line.
I end up with a straight line. See there?
That's nice, yeah.
Can you see that? It's a little bit, I know it's hard to see what that is. Can we see that? So I just put the angles together. See there? And I end up with a straight line.
That's nice.
Yes. Correct.
Good. So what do you think the checklist would be? Can we all see that? So we know that some of the angle of the straight line is going to be 180, definitely. So once I can get this to be a straight line, I know that that will give me 180. So see there? Perfect straight line. I don't know if I can, it's hard for me to show you, but can you see it? Yeah?
Yeah, I just
Good.
see.
Once I can see, then I'm good. So I just showed you that the sum of interior angles of a right angle, and we all know this is 180 degrees. That never just come from the sky either. These are things that are not magical, they're real. So it doesn't matter how big you draw to make the triangle or how small. Once you take out the angles, you'll get 180. Or once you measure the angles, you'll get 180 degrees. And find the sum, you'll get 180 degrees. Are we clear?
There.
Yeah.
Good. Now, if I give students that task, what do you think the checklist will be? What is one of the things that I need to be looking for?
You made the triangle?
Yes, I would make the triangle
So then we
and give it to them to show that.
I guess if
Yeah,
they know what an
question.
angle is.
So if I can identify the 3 angles of the triangle,
Yeah.
that's one thing. What else?
The angle is 180, a straight line equals 180 degrees.
If they know that the straight line equals 180 degrees,
one second. Them have to do that method or what you them decide for
we
that?
can do any method, but let's say they do this.
Okay. Alright, so
Let's
identify the angle, what's the straight line
Ensure
Alright.
that they use a
Yes, Aratos?
ensure they use a protractor to measure each angle that could add up to 180 degrees.
Okay, they could do that too, but they don't have to use a protractor, depending on the method that they're using to make that proof.
Okay.
Yeah. Alright,
They would
so,
need to measure that's good.
But they need to show that they have to come together in order to get 180.
exactly, they need to know that it's the sum of all the angles, the 3 angles that will give me 180. Alright, so, are we clear with what a performance task should look like then?
Yes.
Remember that
Nice to see.
So, Berkeley, it's your turn.
So yeah, that's not possible. Yes. Okay, what to do?
Oh,
Yeah.
okay. We did the volume of a cylinder.
Uh-huh.
So it was find the volume of a cylinder that has a diameter of 8 centimeters and height of 8 centimeters. Our checklist was identify the value of pi,
Well, why?
calculate
Why do I need to
calculate
be
the radius.
Why you calculate the radius? That was the same.
I'm
You said
trying.
why?
Okay, I'm trying to figure out, I don't mean to interrupt you, I apologize, okay? But I don't want you to go and I don't remember later on. Why do you need to identify it's a performance task, why would they need to be able to identify the value of pi? Because a performance task is not a calculate, they're not doing any calculations. Are you getting what I'm saying? So if you look at the activities that we've done so far, we haven't done any calculations because I just proved that the sum of interior angles of a triangle adds up to 180 degrees, and I didn't do any calculation, did I? No. What Christiana did, she did area, but she didn't use any calculation. She wasn't doing any calculation. What they did, the Mona students did, they weren't doing any calculations either. So it's an activity that they'll do, an activity, rather than algorithm or procedure or steps. Are we clear?
Like, what they could have done for volume, maybe,
Yes.
is to make little blocks, a little, 1 cm cube blocks, little ones, and then you give the student a bigger box, and then ask them to place their boxes in there until it's compact or something. I don't know.
But the thing is, for them to be able to, the thing that's how I'm thinking that for you to give a performance task to the students, you yourself as a teacher must know the concept. That's important. So you are able to make that proposition because you understand the concept. Are you agreeing with me?
Yeah.
Yes.
So you have to know the concept for yourself. That's why it's so important for you to know what's the idea behind volume. The idea behind volume is in using the cubes that will occupy the space. So if I have a bigger box, how many little cubes will take up the space of that box? Can I reproduce, use the cube to reproduce that box then of the same size? And then how many of that little cubes will it take? That is the volume of the bigger box. Is that clear to you?
Yes.
So that's why volume is measured in cubic units. Because it's about counting the number of little cubes that is equivalent to that shape there, that three-dimensional shape, that thing that you have there.
Right.
And we know why something is 3D, right?
Yes. So by using the concept, you're saying you, as long as you recreate the space.
Exactly. Well said. That's it. That's exactly it. And you said it's even better than I did.
Okay.
Any picture thing, how many kids could you have in that would be great, that would shoot you over the just why you have to go space, the amount of space. So that's why I'm concerned that you can put a larger, you have a larger box. With
So the volume, yes, and you guys seem to have it now. So the volume would be the number of little boxes that would take up the exact space of the bigger box. And the box would be cubes. The number of little cubes that would take up that space.
Right.
Good.
But the thing is, how would you write the task for that?
Oh, do you write the task about to that? Okay, so use these cubes, the centimeter cubes, to show that or to find the volume of a box that is that, or you can give them the box. You can actually give them the box and for them to reproduce. So they can measure the length and the width and the height of the thing and see how many of the cubes that is equal.
Right.
Yeah. I don't need to go any further, right? That's where I'm getting at. And that's an excellent performance task. That's a very good performance. That would be a very good performance task. Alright, so it's lunchtime. Yay, we get to eat. So we come back in another hour. But guys, I would recommend that if you're not like Bermuda, you've had lunch already, right?
No, we don't have
I'm gonna get something to eat and come right back.
Alright.
Yeah,
So please get some time to look through the assignment. And I've been trying to go through the different things that you need to learn how to do, because the assignment is something practical. And it's something you need to learn to go there and teach. It was emailed to you last night.
Yeah, so when is it due?
I didn't hear that, Rich?
Sunday night.
Last night.
Sunday night.
So what, when do we have to hand it in?
The assignment, oops. I don't know. I was thinking at the end of the week. So let me see. When do you want to hand it in? Sunday night? No, we don't want it to mark it for Monday. You don't want to get the result for Monday? You can send it on Saturday so I can mark it for you to get it back by Monday.
Sunday night.
Sunday night?
Saturday.
No, Sunday.
She's saying Saturday because she wants to mark it for Monday.
Okay.
We haven't got our other marks back. Christiana, you got yours ready?
See you, Arthur.
It's all over your phone. I gave you your okay. So we should do
Well, yes, alright, no problem. Alright, no problem. So I'm available on Tuesday.
It's the
normally it'll be with. Well, that's on the way. That's on the way. Yes. Well, she didn't say.
Thursdays and Fridays.
Are you ready to ask questions?
I